if you have this like really basic equation and you solve it, you know, x equals 3. Okay? If you were to draw a picture of that solution, it would look like this. Just one point out of the entire number line, right? One thing. If you added another number line to this one, you would have two variables in the x and y direction. And instead of just one equation to solve, you would have two. And this is what we've been talking about this week. This doesn't work. It's a random number line going. Although remember the other thing that made up the system and the answer was integers? So if you have this system, and the solution is going to be two numbers instead of just one. And when you draw a picture of that solution, you have two number lines. Still just one point, but now it's representing two pieces of information at the same time. What we're going to talk about today, these are equations. Today we're talking about inequalities. Here's the difference between inequalities and equations. Back in the one-dimension world, when we just had an x, if instead of x equals 3, I had greater than or equal to, I still have this point, but I also have everything to the right that's bigger than 3. That is infinitely many solutions, right? You can pick any number here and plug it into this equation, and it would work, right? Any number. What that looks like in 2 dimensions is a little bit different, and that's what we're going to be talking about today. You're kind of talking about where those things overlap. So we'll draw lines today, and we might need all the information that's below one of those lines, and all the information that's to the right of another one. Where they overlap is what's called the solution to a system. Remember doing that before? We've done that before. So we're going to review today about the algebra that's involved with inequalities, how to shade, and then how to determine where the shaded regions overlap. Okay. Thank you. Thank you. See you tomorrow. So that's what we're doing today. We've got this one system of inequalities in the middle of your paper. We're going to do sections 1, 2, and 3 for that problem. And then down at the bottom right is a second practice problem that has 3 inequalities. I want you to notice, though, on this practice one, that's also part of your I will statement. How many variables are there? 2. Now, we've been doing 3 equations and 3 variables. The reason why we're not doing 3 here is because we're going to be graphing these. And for those of you who have taken something like physics, if you're graphing and you have 3 variables, what is that? It's 3D, right? We wouldn't be able to do a good job of graphing it here. We would need a X, Y, and Z plane. And so that's why we're not going to be graphing. So we do have 3 inequalities, but it's still, they're all just linear, meaning they still all just have either X or Y in a combination. So going back to this example, the very first step, so in the upper right corner of your notes, is to write the inequalities in slope-intercept form. This is helpful both for graphing your boundary lines and deciding which side to shade them on. Otherwise, you have to do some sort of extra Sherlock Holmes thing to figure out what's especially with Robert Downey Jr. because I like those movies. Who's that? I read that's the director. I heard the one coming out. I read it. No. 2x plus, I mean, I like O'Farrell. I like the other ones better. 2x plus y greater than or equal to 4. I might have the director. I think it's perfect. So we need to get the y by itself. We're trying to get it in mx plus b form. What do I need to do to make that happen? Move the 2x over by subtracting. Y greater than or equal to negative 2x plus 4. So that's my mx plus b. Before I do the second equation, we're going to move to the left and graph this inequality. Which piece of information do I need to go first, the 4 or the negative 2? 4, right? That's my y-intercept. So I go to the point on 4. And then the slope is negative 2. That means rise over run, so it's really over 1. So I go down to right 1. Put some points on there. And then before I connect them, though, I have to decide if it's a straight or a solid line or a dash. It's solid because it has this little wiki right here. It's got the equal bar. And the turbulence also just ignore me if it bothers you. I guess you can't tell me too much. And then, so that's just your boundary line, okay? We also want to shade, like I talked about a second ago for inequalities, you have to shade infinitely many solutions. We want to shade the side of the line where all the y values are bigger than the line. So this line represents the negative 2x plus 4. We want to shade all the y values bigger. Now here's the deal with students and shading for inequalities. Half of them get it, like no problem. If I say shade above or below the line, they're like, got it, below the line. And the other half of them are like, what does that mean? What does that even mean above the line? For whatever reason, they can't make it click in their head. So if you're the kind of person who has always struggled with having to figure out which side to shade, here's how I tell students to do. I say, put your pencil on the y-intercept, okay? Because that's a y value. And we know that this is saying I need, it's like a mouth, right? Opening to the bigger value. So y needs to be bigger than this one. So if I'm here, this is 4, right? Give me a number for y that's bigger than 4. 6. Which way do I have to go there? To get there, I have to go here. So therefore, that's the side of the line that you shade. So again, if you're the kind of person who has a hard time with your brain clicking over what side to shade, that's my recommended method. So now let's do the second inequality. Is it already in mx plus b form? No, right? So I got some work to do there. I'm going to start by doing what? Moving the x over by doing the opposite of it. So that's minus x to both sides. And what do I still not like about the y right now? It's negative. So have you undo negative 1 and a y? Divide both sides by negative 1. But this is the little weird thing about inequalities. When you multiply or divide both sides by negative, you take the inequality symbol and you flip it. So that would become y is greater than, and then I have negative x divided by negative 1, it's positive. And then 2 divided by negative 1 is negative. And I have this little and written right here just in case you forget, divided by a negative number, you need to go there. So now I will graph that. Where do I begin on my, where do I begin? The negative 2, the y-intercept. I go over here, I put a point at negative 2. I don't see a number in front of x. What does that mean my slope is? 1. But it's rise over run, so it's not just 1, it's 1 over. So I go up 1 and to the right 1. And does this need a solid or dashed line? Dashed. And by the way, for inequalities, a dashed line means any point on that line is not truly a solution. It's a boundary line, but it's not a solution. If the line is solid, then any point on it would be a solution. It would satisfy the inequality. So, do I need to shade above or below that line? Above, because when the inequality symbol flips, its mouth is open to the y. So I want all the y's that are above the line. And if that's hard for you to imagine, you just put your pencil on the y-intercept at -2. Do I want, give me a value that's bigger than -2. 1? So that means, well, here's 1 for the y value. So you're going to shade on that side. Everything above that line. Let's see. That's just in the middle. But even that's not your answer, okay? This is just your work. Your actual answer is this. It's a region, and it's the area that the two shaded regions overlap. It's what they have in common. So when we were just doing lines only, what they had in common was the point where they intersected. When you're doing regions, it's where the whole regions overlap each other. So it's where the red and the blue intersect. And that's this right here. When you are taking your test after spring break, isn't it great? We're about to be on spring break. So excited. When we come back and we do our test for spring break, it won't be enough to just show me your shading areas. I want you to either use a different color or highlighter to mark your overlapping region like I did here, or if you're not a color or highlighter person, you just like your pencil, make it real dark, okay, that area. You need to show me that you understand what your solution area is. Okay, so that's our picture. If we wanted to test this region to see if we did everything okay, we would just pick a test point here. Give me a point that looks like it's in that area. 3, 3, excellent. Let's do 3. So we're going to pick a point from that region. Did we get out of 25? What is the time going? So you plug it into both inequalities, 3 for x, 3 for y, and you're checking if it checks. So for the first inequality, I have 6 plus 3, which is 9. Is it true that 9 is greater than or equal to 4? Yes. So that checks. So far, so good. But you have to check the second. What is 3 minus 3? 0. Is it true that 0 is less than 2? Yes. I can't believe you didn't get this last problem. It's all the time all day. We'll do that for a warm up in the oh, we will do it tomorrow. Let me pass out the homework. Okay, so on this last example, we want to get the first inequality in mx plus b1. So I do that by dividing both sides by 4. So that gets me y less than 3/4 x plus 3. And the reason why I didn't flip the sign even though I was dividing is because it wasn't my negative number. So I have that it looks like this. My y-intercept at 3. My slope of 3 over 4. And it needs to be dashed. And I'm shading below. So here's the y values below. The second inequality is different looking. It means we want all the x values that are both greater than 0 and equal to 0. So I'm going to do this one first. The line where x is equal to 0 is the y-intercept. I'm sorry, the y-axis. Everywhere on this line, x equals 0. So that's this side. We also want to shade all the x's that are bigger than 0. So that's everything to the right. And then the last thing is the y less than or equal to 1, x plus 1. So we just put our y-intercept at 1, and then our slope of 1 over 1. Just do that for a while. I have to do it till it crosses. And it is equal. And we want everything below. And our final solution is where those three colors overlap. So it's to the right of the blue straight line, and then under the green. So it's kind of hard to see. It's basically this. And that's it.